Hello, class. We are looking at this week tangent segments, and the notes are split up into 2 days. So just so you know, you will get a day one today and a day two tomorrow. Day one, first of all, the notes talk about what are tangent lines, a point of tangency, a common tangent, and what it means to be a tangent line. So looking at all of this vocabulary, again, know what a tangent line is, a point of tangency, a common tangent. It's just a line that would be within two circles. And then this one here, very important, marking it right now, the third bullet, it says a line is tangent if and only if it is perpendicular to the radius. That is very important with today's lesson. And then knowing that a tangent segment can be made into connecting a point and possibly a triangle. So looking at this example down here, you can see connecting P to S and then having a tangent line with radius, you're going to see right triangles. And if with having right triangles, you can use the Pythagorean theorem. So we're going to look at some examples here. Now, the first theorem that we have is called tangent segment theorem. And it says if two tangent segments are drawn from the same point on the exterior of a circle, then the tangent segments are congruent. So looking at the picture here, if I have a tangent at point JH and another tangent from point F to H, then I know those two segments are going to be equal because they meet at point H. So again, reading the theorem, if segment JH and segment FH are tangents, then we know that those two segments are congruent. So let's look at some examples here. And again, I'm not going to go through all of them, but I just want to go through some of them with you, okay? So looking at question 1, it says in the figure, line KP and KS are tangent to circle W and angle PKS equals 46 degrees. I'm going to mark this. Calculate the measure of angle KPS. So I'm looking for KPS. Well, it tells us that we have two tangent lines. So those two tangent lines, I know they're going to be equal. And if you look at the triangle that we have, triangle PKS, it's an isosceles triangle. And the isosceles triangle tells us that two sides of a triangle are equal. Therefore, the two base angles are equal as well. So our base angles are going to be congruent. So we're going to do a quick 180 minus the 46 that we have, and that's going to equal 134. And then we're going to divide that by 2 because that's what's left of the two angles. So that's going to equal 67 degrees. So our answer for the measure of KPS equals 67 degrees. Question number 2, it says in the figure, line PS is tangent to circle M. Now notice that PS is connected to the radius, and up at the top it said if and only if it's perpendicular. So I know right away that's a 90-degree angle. It also tells us that the measure of angle SMO is 119 degrees. Calculate the measure of MPS. So they're asking for that top angle up there. So again, seeing your triangle, you know that the exterior angle is 119. So I'm going to use 180 rule because those two side by side are supplementary. So I know this angle equals 61. And then now I'm going to find the angle that's missing by using my triangle rule, which is subtract my two angles that I have, which is the 90 and the 61, find that third angle. And that third angle would be 29 degrees. So that would be the measure of angle MPS. Okay. Moving on, and these are, again, more examples. If you have any questions, I'm going to not do all of them, okay, but I'm going to do some. Looking at question A, I'm looking at number 3. This one, quick and easy. If I see my two tangents connecting to the same point, I know those are going to be equal. So set up your equation and solve for x. And doing the math, I'm just going to say x equals 2 there. Question number 4, again, a tangent with a radius that is perpendicular. Now, this is the first time seeing this one. This one is using the Pythagorean theorem. So I'm going to say 15 squared plus 10 squared equals x squared. Okay, mark your right angle and you can see where the two legs are with the hypotenuse. And again, this is rounding, because it does say round if necessary. You get about 18.0 there. Okay. Question number 5, it is asking, determine whether each segment is tangent to the given circle. Justify your answer. So what these questions are asking, is this perpendicular at that point of tangency? And I'm just going to skip to the answer key, and you can see here with question 5 and 6, the work for the Pythagorean theorem, and pretty much what you're asking, are they equal? This one is not equal, so therefore it's not tangent. These two are equal, so then that means that they are tangent to one another. Okay. Looking at the next two questions, these are multiple tangents that you have. You have a tangent here at point C. You have another pair of tangents at point B. And then you have a third set of tangents at point D. So those are all equal. I shouldn't say all of them. Each set is equal. So you have 3x equal to the 18. Then you have the 12 equals BV, which that would equal 12. And then you have this one here, which you have to figure out what those two equal. And 52 minus the 18 on this side is going to equal 34. So you know this part right here from U to D is 34, so that equals 34. So pretty much solving each set of tangents, you're going to be able to find the perimeter of the figure. And again, just looking at the answer key, you can see how those work out. So I just kind of wanted to do one and then just do one set at a time. Hopefully color coding that helps. And then the last question, very similar to that last one. This is just relating to a clock and seeing how that also works out. Again, finding the perimeter of that outer figure. If you have any questions, please email me, reach out to me during my virtual office hours this week, and look at the answer keys for both the notes and the homework. Take care.